In this question, we're told that the number 864 is the product of 20-something multiplied by 30-something. And essentially, our job is to figure out what the 20-something and 30-something are. Now, every data sufficiency question requires at least one of the statements in order to be able to solve it. So just from knowing the rules of data sufficiency, we can infer, reading this question, that there's more than one way to get to 864 via multiplying 20-something times 30-something. How many ways? I don't know. If there are only two such ways, then our job is just to eliminate one of those and we're left with the other one. But there might be more than two, and I just don't know how many there are, so I'm going to have to do some work here. Since 864 is a product of two factors, it's a good idea to start working on factoring down the number 864. There's a fast way to do that, and there's a slightly less fast way to do that, and there's a very slow way to do that. The fastest way to do it is to identify that 864 is a difference of two squares. If you think of 864 as almost 900, and then you wonder, well, how much below 900 is it? You'd think of it as 900 minus 36, or 30 squared minus 6 squared, or 30 minus 6 times 30 plus 6 using that special product. So I think that's the fastest and coolest way to break it down, and you get 36 times 24, which happens to be 30-something times 20-something. So in my opinion, this is what the creators of the question had in mind as kind of the best way to approach this question. The slightly less fast way to factor out the number 864 is to identify that 800 and 64, each of those numbers is a multiple of 8. So you can factor out 8 right off the bat, and you'd have 8 times 108, right? Because there's 100 8s in 800, and there's 8 8s in 64. So 8 times 108, and then kind of keep working down from there. So, of course, 8 is 2 cubed, and 108, divide that into 2 times 54. 54 splits into 2 times 27. 27 is 3 cubed. So now we can write down the prime box of 864. I'm counting a total of 5 2's, right? It's 2 to the power of 5 times 3 cubed. Now, if you choose to think of it as 2 to the power of 5 times 3 cubed, you identify another way to get to the product 864 multiplying 30-something times 20-something, right? Because 2 to the power of 5 is 32, and 3 cubed is 27. So now I know of two ways to get to 864 by multiplying 30-something times 20-something, right? So the first one was 36 times 24, and the second one was 32 times 27. Now, it's probably a good idea to consider, are there any other ways, other pairings of 30-something and 20-something that could get us 864 before we go to the statements? To do so, we can just look at the prime box of 864. We know we have just 2's and 3's in there, right? It's 5 2's to work with and 3 3's. We looked at 3 cubed is 27. If we replace one of those 3's with a 2, what would we get? It would be 3 squared times 2. That's 18. That's not enough. We're just looking for 20-something times 30-something. So going below the 3 cubed, by replacing one of the 3's with a 2, that doesn't work. What if we replace one of the 3's with 2 2's? What would that be? That would be 2 squared, 3 squared, that's 36. Well, we already had 36 in our first pairing of 36 times 24. Okay, what if I replace another 3 with a 2? So now we have 3 to the power of 1 times 2 cubed. That's 24. We already had 24, again, from that first pairing. So it doesn't look like there are any other numbers I can get to from this prime box in that range of 20s and 30s. Right? We have 24, 27, 32, and 36. That's it. I can't construct any other numbers in the 20s or 30s using the contents of this prime box. So now I'm ready to go into the statements, knowing that all I have to do is eliminate one of the two possibilities. So to recap, we have 36 times 24, or we have 32 times 27. In other words, the square and the triangle are either 6 and 4, respectively, or 2 and 7, respectively. Now, statement 1 tells us that their sum is 10. Well, then it has to be 6 and 4, because the sum of 2 and 7 is not 10. So statement 1 is sufficient on its own. Statement 2 tells us that their product is 24. Well, then it has to be 6 and 4, because the product of 2 and 7 is not 24. So it turns out that each of these statements is sufficient on its own. We can go ahead and pick answer choice D and move on to the next one. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.